Okay, I have to say I really like this problem um, because I like it's making a point. It's not just asking me something, but it's trying to make a point, and I think the point that it makes is kind of cool. So let me zoom out here. So it says that I need some graph paper, and I'm being asked to graph point A at 2, 4, B at 9, 5, and C at 4, 10. So I think if I zoom out enough here, there's room for me to include or paste some graph paper here. That'll work. And I'm going to go ahead and plot those points, right? So here's point A at 2, 4. There's B and C, and let me draw this triangle. And the first thing it's asking me to do is verify that D at 3, 7 is really the midpoint of AC. So let me go ahead and draw these points in here. Beautiful. And if I go from A to C, right, you can see I'm going up 3 and then over 1, and then I go up another 3 and over 1 again. So I can see that that point right there is indeed at 3, 7. So I'm just taking half the rise, half the run. The other way I can do that is I can, if I'm asking is D really the midpoint, I can take the x values, right, 2 and 4, I can add those together and divide by 2. 6 divided by 2 is 3, so I get that 3 is the value of x at my midpoint. Same thing with y, right? I could take the 4 plus 10, I get 14. Half of that is 14 halves, which is 7. So I can see that absolutely, right, absolutely D is the midpoint of that line segment. So first thing confirmed, D is the midpoint. The next thing it asks me, it says write the equation of the line that goes through points D and B. So D is the midpoint, and B is this other point way over here at 9, 5. So what I'm being asked to do is find the equation of the line that goes through 3, 7 and 9, 5. Okay, and I think we can do that. So through 3, 7 and 9, 5. I guess the first thing we need to do is probably find the slope. So the slope for those, if I'm looking at my change in y's, I've got this, I'll go 5 minus 7, which is negative 2, and then I'm going to go 9 minus 3, which is 6. So I'm going to have this negative 2 over 6, which is negative 1/3. So my slope is negative 1/3. Then I could use either one of those points, right? Y equals mx plus b. I'll use the point with the 9, 5. So 5 is my y value, is equal to negative 1/3 times x, which is 9, plus b. Now if I solve this, right, negative 1/3 times 9 is going to give me a negative 3. And if I add 3 to both sides, I'm going to get that my y-intercept is 8. So my equation here is y equals negative 1/3 x plus the number 8. Okay, that's the equation of the line that goes through those 2 points. So that's fabulous. That's fabulous. So I got the equation of that line. So the next thing that I'm going to do is it says is BD a height of the triangle? So here's the thing, for any segment to be a height of a triangle, it has to be, let me say this slower, if it's going to be the height, it has to be perpendicular to the base. Okay, so if this point D really is a height, right, it has to form a right angle with that base. So so that means that if I was going to draw this line through here, let me grab this pen, right? The question is this really a height? Well, let's see. This thing had a slope. This thing had a slope, we said, of, let me go back to it. The slope was negative 1/3, and the other one had a slope of positive 3. Well, because I've got those slope, one slope is negative 1/3, and the other slope is positive 3. Yeah, those are opposite reciprocals of each other. So I know absolutely that line BD is a height. So what I could do to find the area of that triangle is I could multiply that length of that segment that I just found from D to B. I could multiply that by the segment from A to A to C. The length of those two segments multiplied together, and half of that would totally give me the area of that. Now, that was a lot of fun, but I don't think I'm going to find the area that way. And here's why. What I'm going to do instead is I'm going to think about these little bounded rectangles around it, and I like the area. Um, I like the well. If I'm finding the perimeters, right? That 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 one green one, this hypotenuse here is going to be for this segment. That segment is going to be the square root of 50. This blue one is going to be the square root of 50 also, isn't it? 25. That's going to be the square root of 50 also. Oh, that means that was actually a equilateral triangle because I got two root 50s, and then this one along the orange bounding is going to be the square root of 40. So the perimeter of that is the sum of those three. Now, in terms of the area, the length of dB. So if you look at real closely, the length of dB, that's that line segment that I added. I've got this 2 squared, right? This little piece is 2 squared, and that other piece was 6 squared. So you can see this purple triangle here is 2 squared by 6 squared. So that has a length of root 40. So if I want to know the area of that, kind of cool, I'm going to multiply the square root of 40 times the square root of 40, which is 40, and then I'm going to take half of that. The square root of 40 times the square root of 40 is 40, and then half of that gives me that the area of this thing is going to be 20. And then the other thing that I'll finish this with is the area of that is going to be 20. And then the perimeter is a little bit more, right? The perimeter, I've got this root, I've got two root 50s, right? There was one of them with the green, one of them with the blue, and then the other one is a square root of 40. So I can write my perimeter like that, or I could find it as a decimal approximation. Anyways, I know that's 7 minutes. Probably I enjoyed that problem too much, but it's kind of cool to think about how I could find an altitude like that, find the height of a triangle using a midpoint. It's not always going to work, and if it's isosceles, it'll work. It doesn't always work, but it worked there because it was isosceles, using a midpoint and finding that. All right, let's stop.